Good evening, everyone, and welcome to our program tonight. I'm Dr. Cindy Russell, co-chair of the Santa Clara County Medical Association Environmental Health Committee. Thank you all for joining us for our third and final Environment and Health webinar series in 2024. This is part 3 of our series, and we are going to be discussing tonight environmental toxins, environmental illness, root causes, and prevention. This webinar will be recorded and will be available at our website at sccma.org, along with the first 2 presentations on confronting climate change and artificial turf. We have 3 incredible speakers tonight, Dr. Christopher D'Adamo, Dr. Pete Myers, and Dr. Ray Dorsey. They are going to help us understand tonight why we are witnessing an epidemic of chronic illness in this country. Chronic illness is now overwhelming the practice of medicine, and according to the CDC, more than half the population of Americans suffer from a chronic illness, and almost 30% have multiple chronic diseases. Often they're progressive, they're not curable, and they exponentially complicate medical care. Neurologic diseases such as Alzheimer's and Parkinson's are rapidly increasing and a leading cause of ill health and disability globally, with 3.4 billion people affected worldwide. That's billion. These illnesses not only affect the quality of their patients' lives, but also that of their family. The cost of medical care has skyrocketed and become an individual and national burden, with an enlarging cycle of increased pharmaceutical use and pollution, medical waste, and energy consumption. The CDC states that 90% of the nation's $4.5 trillion in annual healthcare expenditures are for people with chronic and mental health conditions. Scientific research is revealing the connection between chronic disease, genetics, and preventable environmental factors. And these external factors have a direct effect on our biological processes. They can alter our genes. They can also alter the genetic expression of our genes and thus lead to disease. So we have not only many chemical toxic exposures and heavy metals, but now microplastics have been added to the list. Our 3 speakers will discuss some of the root causes of chronic diseases and help us understand how to prevent them. I want to let you know that for the webinar, you're muted. We're going to take questions from the Q&A box, and after the webinar, we're going to go ahead and answer these, but don't put anything in the chat box. We're going to use that to provide links and resources to you along the way. I am delighted to introduce Dr. Christopher D'Adamo, who's going to present Total Load, the synergistic effects of modifiable lifestyle factors and environmental exposures on human health. Dr. D'Adamo is a distinguished epidemiologist with expertise in the synergistic effects of healthy lifestyle practices on human health and wellness. He received his PhD in epidemiology from the University of Maryland School of Medicine, and he's currently an assistant professor with dual appointments in the Center for Integrative Medicine within the Department of Family and Community Medicine, as well as in the Department of Epidemiology and Public Health. He serves as the director of the Center for Integrative Medicine at the University of Maryland, which is the first academic-based integrative medicine center in the world. He served as principal investigator on a wide variety of observational and interventional studies on nutrition, physical activity, stress management, and multimodality, integrative and functional medicine interventions. He's published his findings in highly regarded peer-reviewed scientific and medical journals, including the American Journal of Preventive Medicine, the Journal of Nutrition, the Journal of Nutrition, Health, and Aging, and the Cochrane Database of Systematic Reviews, which is the leading database for systematic reviews in healthcare. You have been a curious and prolific researcher. Dr. D'Adamo, thank you so much for being here to share your knowledge.
Thank you for the introduction, and good evening, everybody. Look forward to presenting this topic, which I find incredibly interesting on total load. And I think this is where things are going to be going in a lot of ways, as challenging as it may be, as you'll see as we go through this evening. I'm going to focus particularly on our work with children, which I think is particularly concerning given the increase of environmentally linked chronic diseases, but in many ways also encouraging in that we're starting to get a better understanding of many of these issues. So, we think to really get to the root of this, that a paradigm shift in understanding is required. Much of the research to date has been looking at, a single molecule that may be pernicious and how that impacts the system. And that work is important. But the reality is in our modern living, we are just bombarded with dangerous molecules that interact with one another, stress that we face, lifestyle factors, all of these kind of collude to create a lot of problems potentially. And getting a better understanding of those interactions is really what our team has been aiming to do in recent years. And the framework for this has actually been in the literature for some time, and it's called allostatic load. We often refer to it as the total load. But the graphics I'll show here, I think, give a pretty good understanding. It's essentially, our ability to balance the stressors that we all face in modern living, many of which are external. We're going to hear about some of them tonight with, plastics and pesticides and these types of things in our environment. But other external things, negative stressors that we face and so on. And then a wide variety of internal stressors, many of which have to do with lifestyle choices, but also, emotions and so on. So you have those that sort of fill the bucket up, and it's being weighed against, the health protective measures. So, our healthy lifestyle factors, being in a clean environment as best we can, managing stress, all these types of things. This is really the way to think of this framework, and conceptually. And in terms of how is it measured and assessed? And there's again been a lot of good work done on this. Typically, it's first reflected in what are called primary mediators, which are essentially just biomarkers of stress. So these could be stress hormones. It can be measures of inflammation, other biomarkers that reflect that something isn't right. If this goes on unresolved for enough time, this can lead to chronic illness. Heard Dr. Russell talk about some of the statistics, which are sobering. And if it goes on even longer, this can and has been shown to lead to death. So as you can imagine, given all the different factors you see here, and there are many others, of course, it would be difficult to measure just single items. So it's often measured using indices, where groups of stressors will be put together in an index, and health promoting factors will be put together in an index. And I'll go through what some of these are as I go along this evening. So again, the data are pretty clear that this total load is associated with, both mortality, our top two leading causes of mortality in cardiovascular disease and cancer in the US. And again, even with the rising incidence of chronic disease among children. And there's been a call for more research in this area for better understanding. And that's what our team has been doing. So I'm the scientific director for Documenting Hope, which is, the mission really is to get a better understanding of what are the root causes of the chronic disease epidemic among children, and what can we do about it. We've got two main studies going on. One, CHIRP, is a survey looking at risk factors for chronic disease. So observational study, and then there's a flight intervention where we're directly intervening based on some of the knowledge that our team has uncovered and many others across the world. So I'll start with a little bit about CHIRP and what we're doing, what we've found so far. So, again, we're taking this total load framework that's so well established in the literature, and these are some of the types of things that we're looking at. There are some good databases out there, NHANES and so on, that get into a lot of these types of factors. But I don't think we've published NHANES data, but not quite to the extent of how deep we're going with this. You see here, I'm not going to go through the entire list, but these are many of the types of things that we're looking at. Clearly a lot of environmental factors, different medications, lifestyle factors, stress, a lot of parent history. So we're really going quite deep on this. Let's see. Okay. And what makes this particularly challenging is that, there's so much bioindividuality where you could have the same, let's say someone who's, I'll just random thing here, living near a trash incinerator, and the air that they're going to be breathing and possibly the water they're going to be drinking is, going to likely be increasing the risk of disease. Now, that may be the straw that broke the camel's back in some children, but others, it'll be something else altogether. So depending upon an individual's genes, what other exposures they've had, which it makes this challenging, is to know, well, what exactly did it? It's usually not a single root cause, but some interaction between the things you see on this list and many others as well. And it will manifest differently. We know about the increase in autism, and I'll talk about some of our work with that, but asthma, ADHD, metabolic issues, there are lots of factors that are contributing to this, and it's just difficult to know what they are. CHIRP is again really trying to get to this and be able to look at these risk factors, synergies, interaction terms, using decision trees and really advanced methods to be able to get a better understanding of how all these factors are interacting. So actually, the study's actually on hiatus right now. We're going to be picking back up. We're migrating to a new platform in early 2025, and there's actually a report that the parents, again, this is for children ages 1 to 15, will get, that goes through, stressors that were identified, health protective factors that were identified, and so on. So I'm going to share some of the findings that we have to date out of CHIRP, predominantly been presented at conferences, including the Institute for Functional Medicine, where we've presented most recent years. These are the stressor indices that we've put together that are the focus of the analyses. So there's 24 that you see here that cover a wide variety of areas, both internal, external stressors to the child, stressors that might have been faced by parents. So there's a lot here. And just to give you an example, that these all go pretty deep. So antibiotics is the stressor index that we have found most consistently associated with chronic disease in our sample of about 500 participants so far. So we want to get that much bigger, obviously, but that's where we are right now. But it's not as simple as, antibiotics, yes or no, a binary. It's far more detailed than that. So we'll get into, how often were they taken and at what time, looking at cumulative exposures, looking at exposures during particularly vulnerable periods of life, the first year of life being one of the most vulnerable, consecutive, and had to go back-to-back prescriptions, and more. So, the route of administration, we've seen those that were injected tend to be a little bit more problematic than oral. So there's a lot there. And again, we get into parents and guardians and other exposures that may have affected the children. So there's a lot here that we really dive into. And what we found, and I think this really validates this total load theory, is that if we look at any single category, the correlations you see in the boxes on the left, they're not terribly strong, about 0.1 or less for any of the individual ones, even ones that are pretty important, like environmental or immune stressors. But you start to stack these with one another, those that would happen to have environmental and immune stressors, the correlation between that and our chronic illness index was higher, about double. But where this really starts to take off is when you look at this total load. If you look at all of the stressor indices, you look at all of these indices that we had captured here, the correlation with the illness index, which you see how we defined it there, it's the number of diagnosed conditions and some other parameters. Correlation is about 0.64. So that's getting to the point where it's a moderately strong correlation. So there's clearly something to this, even within the data that we have thus far. Now, again, we think total load is kind of where the thrust of what's really happening is all about. But it is important to be able to sort of deconstruct these indices and get back all the way down to the level of an individual question, so desired, which we have done, which is we look at the relative importance of the different indices. And as I mentioned a moment ago, the antibiotics index is the top association with chronic illness. EMF index, I'll talk a little bit more about that, was the second. So these are a lot of the devices, mobile phones, Wi-Fi, cell phone towers, these types of things. Chemical exposure index was third, and then various prenatal exposures were fourth, and you see all the way down to the bottom. So it is pretty interesting. And then we can also look at, well, for each of these different indices, what are the specific conditions that are associated with that? So if we look at EMFs, electromagnetic fields, for example, this with ADD, ADHD, asthma, chemical sensitivity, and so on. So we're able to kind of, get some granularity with this as well. And I'm not going to talk very much about the flight study, just in the interest of time, but I do want to talk a little about how just demonstrate the synergy between these two studies. So, we had seen some of the data emerging pretty early on that exposure to high level of non-native electromagnetic fields. Again, we have some just by living on Earth, but we're talking again, cell towers, Wi-Fi routers, high voltage power lines near someone's house, these types of things, or even the electrical wiring within someone's house. So this is an interesting story. One of the children in the flight study had alopecia universalis. And the etiology of that was really interesting. He had no issues whatsoever until he was 4. And the family welcomed another child and he moved rooms. And within, a month or so, or even less, I think, of being in the new bedroom, he started to lose hair all over his body. And, on his head, eyebrows, everywhere. And which was what brought him to our study. And we brought a building biologist in. We did the whole deep dive assessment on diet and stress and all these types of things. And the building biologist had professional equipment that you see on the left there that demonstrated that there was some kind of problem with the electrical wiring in the house, and it was measuring electric fields that were about 50 times higher than what is considered safe. As most people do, the bed was right against the wall where the electric wiring ran. So when the child, they actually moved the bed away from the wall and did some other mitigating factors, and he started to regrow hair. Sleep was better. As you can imagine, sleep was not very good with this. And these are the kind of things, I mean, you got a question, would you ever think about this, as a root cause and a differential diagnosis for something like this? I mean, so it's just really interesting to see some of this stuff and some of the new knowledge that is coming our way with this. But in any case, that's just an example of how we've intervened with these data as well. So what we found to date really is that, again, this total load of stressors is really what seems to be most strongly associated with chronic illness, far more than any single factor. Though the single factors, the hierarchy, at least at this point in time, we get more data, it might change, where antibiotics pretty clearly the top, and then EMFs, chemical exposures, and prenatal exposures. And the greater number of stressors, the more the illness index is affected. So we do think there are synergies in this. And we've heard this quite a bit, where there's like a mold exposure and then people have greater sensitivity to fragrances or whatever else it might be. So this is not all that surprising, but pretty interesting, especially in children. Now, one of the I mentioned I was going to talk a little about autism. That's one of the areas that we've had some interest with this, and we're again using decision trees and other machine learning types of analyses. I'm an epidemiologist by training, but some of this stuff even starts to make my brain melt a little bit. There's a lot to it, but that's required when it comes to the complexity of things like this. So we're working on that, but I want to talk a little bit about a publication we had that I gotta say is probably the highest exposure publication I've ever had. I was not expecting that. It was a case report of 2 twin girls, fraternal twins, that had just a dramatic reversal of their autism symptoms using an approach that was geared towards addressing the environment and the lifestyle of the children. And you can get this as open access, so you can download it and take a look if you're interested. But I'm going to go through the timeline, which is really the heart of any case report. So again, these girls are young, and we see that they had a diagnosis of autism in 2021. You see in the red there. And for those who aren't familiar with it, ATEC score is it's a way of assessing kind of severity of autism symptoms. And it's something that's actually designed to be sensitive to intervention. Unlike the diagnostic tools like the ADOS-2, which the girls had, we're also tracking their ATEC scores throughout. Now they essentially they came across a Documenting Hope group and put into place a total load informed intervention that if we look at some of the types of therapies that they did a deep dive on the home environment, on diet. They did some structural things with refluxes, craniosacral therapy, a whole bunch of optometric evaluations. So they really looked at a variety of different therapies and put them into play. And we see at the bottom, so this was at the time this was published, the ATEC scores, so lower scores better, went from 43 and 76 down to 4, which is not considered autism anymore, and 32. And the girls apparently have continued to improve even since this was published. So this was pretty encouraging. Again, I just the amount of exposure that this got, it was surprising to me, at least for a case report. So, you'd expect that from entities like the Defender or so on that certainly recognize the impact of the environment and lifestyle on the health of children, but it just went essentially viral all across the world. And, we received hundreds of emails from parents, many sharing similar stories, many others which were heartbreaking and just wondering, because this is not going to work for everybody. So we clearly said that this is not, again, we observed this, we didn't lead this treatment, but we do think that there's a lot more that can be done with this by looking at the environment and looking at lifestyle for many of the challenging symptoms, whether it's, these girls had just crippling GI problems that were almost completely resolved. So it was interesting. Now, it's nice to see the increasing recognition of the impact of environment on, autism symptoms, but not everyone was positive. There were some that really don't want to hear anything about, that any of this might be modifiable. Even saying it was insulting, which was interesting. This was a parent-led intervention, but that's just where we are. But it is encouraging to see that there is so much interest in this. And, on that note, we actually are holding a conference in November where we're going to be presenting. We've got presenters with expertise, across the board, again, for a total load sort of approach. We're all kinds of things from, chemical exposures in the environment to, other clinical practices and so on that we think can be quite helpful for children. And this is a CME offering conference, and there's a discount there. You can certainly check out the conference website if you like, but we'll be diving deep into a lot of these different types of things in the conference. So feel free to email me if you have any questions, and appreciate the opportunity to share some of this information with you.
Thank you so much. That was a wonderful presentation. And I know Dr. D'Adamo has to leave now, and but if you have questions, then you can email him, or if possible, we can possibly do this if you put your questions in the Q&A. Thank you again. It was a wonderful presentation, and I'm impressed when I've read all of Dr. D'Adamo's articles, and they highlight the connection of nutrition and disease, everything from ultra-processed foods to lycopenes and a lot of issues, spices, celiac disease. So we really appreciate your dedication to advancing this critical research on natural medicine. And it's challenging because it doesn't really garner much in terms of funding, I'm sure, considering that exercise and diet are not patentable, but it's very important for physicians to understand this and apply it to their patients, both adult and pediatric. So thank you so much. And hopefully this is going to be a game changer. This knowledge is going to really start to change it. Even if it's not used by everybody, it's going to change have a positive impact on the lives of the patients and also help physicians. So thank you so much.
You're welcome. We hope so. All right. Take care. Thank
you.
All
right. Take care. Thanks.
Bye-bye.
Bye-bye. All right, that was great. And now I'm honored to introduce Dr. Pete Myers. He's going to be presenting the impact of plastic chemicals on the health of current and future generations. Pete Myers is a PhD. He's founder and chief scientist of Environmental Health Sciences, a not-for-profit organization that promotes public understanding of advances in scientific research on the links between environment, including climate, and human health. And their motto is "Change starts with science." Dr. Myers coined the term endocrine disruption in 1991 and is one of the world's foremost scientific thinkers on challenges related to endocrine disrupting chemicals. He co-authored the best-selling book in 1996 that's still a classic, Our Stolen Future. This book alerted the world to the hormone disrupting effects of toxic chemicals and their threat to fetal development. It's an excellent book, and I read it soon after it was published, and I found it to read like the hot zone. It was just one scientific sort of research study after another that was identified. So it's a wonderful book. Dr. Myers is an adjunct professor of chemistry at Carnegie Mellon University in Pittsburgh, Pennsylvania, and co-founder of the chemical startup SUDOC, Chemicals in Balance with Nature. At Carnegie Mellon and elsewhere, he works to help chemists design new chemicals that avoid health hazards. Dr. Myers also served as director of the W. Alton Jones Foundation in Charlottesville, Virginia for over 10 years, and he served on a number of boards. He's won numerous awards for his work and was named one of the first ever champions of environmental health research by the National Institutes of Health. It's interesting that he trained originally as an ornithologist. His study of birds and his observations of their unnatural behaviors around the world spurred him to explore for over 3 decades the effects of toxic chemicals on our environment and our living species. And if that was not enough, in 2017, he received an award from the U.S. Forest Service for his efforts in 1995 to protect over 39 million acres of migratory shorebird habitat in 100 critical migration sites from Tierra del Fuego to the United States and Canadian Arctic through the Western Hemisphere Shorebird Reserve Network. He holds a doctorate in biological sciences from the University of California, Berkeley, and a BA from Reed College. Welcome, Dr. Myers. We're very honored to have you join us tonight.
Cindy, thank you. My slides are up, are they not? Excellent. So I'm going to talk about endocrine disruption and what it is telling us about the plastic, what I call the plastic conundrum. How do we find a path forward to protect health? So there's a lot we don't know about plastics in human health. We know even less about microplastics in human health, but we know enough to be really concerned. That's especially true of the chemicals that leach out of plastics. Chemicals like the bisphenols, the phthalates, brominated diphenyl ethers, perfluorinated compounds, all those nasties you've probably heard about. What we know is once they get into our bodies, they can wreak many types of havoc, especially hormone havoc caused by endocrine disruption. Now it's my machine. I should be able to make this work. Oh, there we go. But I'm going to start with a story about my granddaughter. My granddaughter was born 2 months premature. She spent the first 2 months of her life in the NICU. She was born weighing only 2.5 pounds, which I'm sure some of you know is not a good prognosis for how she might do in the future. My daughter, her mother, was rushed to the hospital in the middle of the night in January of 2019 because she had developed preeclampsia. She needed an immediate cesarean, and that's why Sierra, my granddaughter, spent her first 2 months in the NICU. And there you have the NICU. I think when my granddaughter Sierra grows up and learns about this trauma, she might be tempted to shout, "Thank you, plastic." Her survival was only possible with a lot of the NICU's life-saving equipment, including a lot made of plastic. And when I think about plastics from this perspective, I have to admit, I'm thankful for what it is capable of bringing us. But there's another side to this story. I'm sure living in the Santa Clara area, all of you will remember the Paradise campfire, November 2018, 88 dead. This is Paradise after the fire. This is the plume of the fire going from, can you guys see the arrow? I hope. Doesn't really matter. The plume of the fire in Paradise, just north of Reading, went from there down into the Bay Area where my daughter was living in November of 2018. I was actually there, and it's where the smoke wound up, right in the middle of Montecito in Oakland, above Oakland, where my daughter was in her 20th week of pregnancy. I was present also. I'm from the East Coast, but I happened to be out there those days, and it was terrible. It's not the worst air now. It's gotten worse even with the most recent fires, but it was really bad. And I immediately began to wonder, once my daughter had to go in for the cesarean, is there a link between that sort of smoke, which is full of plastics, because those were houses that burned and they're full of PVC plastic and bisphenols and phthalates and all sorts of things. Is there any known link between exposure to those chemicals and preeclampsia? And frankly, there is. I quickly, literally within 15 minutes, I found an article by some of my friends about urinary concentrations of BPA and phthalate metabolites measured during pregnancy and the risk of preeclampsia. Now, I know that's not a scientific finding, but it sure raised some questions in my mind. And then Leo Trisande, who's a major pediatrician at New York University, just published this study in Lancet Planetary Health, where they measured phthalate exposure and adverse birth outcomes in the US, a prospective analysis of births and what that might be causing. They estimated in their conclusions that roughly 56,000 phthalate attributable preterm births in 2018 were associated with phthalates and a cost of $3.84 billion to the United States. Again, I can't prove why this happened to my daughter and granddaughter, but I think it really raises issues about the exposure to several types of plastic compounds and preterm birth. So here's a conundrum that we face. NICU, plastics support life, but they're not inert, despite protestations from the industry. Why did that go blank? We know that they can undermine health. And what we also know is that the scale of plastic production today overwhelms human, that's not right, overwhelms human and nature's ability to take care of the West. This is just a waste pile of plastic. And here is the predicted future of plastic production. We are right here in where the X is. That's the amount of plastic that's being produced this year, estimated by the industry. And if they follow business as usual, by 2050, that amount of plastic production is going to triple. You know what? If it's bad enough now, it's going to be unsupportable by 2050. So what are the plastic challenges to health? We've got chemicals in plastics, and we've got micro and nanoplastics. Now, I just have 20 minutes. I can't talk about micro and nanoplastics. You can ask some questions about that. I have been looking into that carefully also. But with respect to the chemicals in plastics, there was a fascinating report published by Norwegian scientists and European scientists in general, called Plastchem, came out in April of 2024. Roughly 16,000 chemicals can be found in plastics, all told, if you look across the industry, the plastic chemicals that have been reported to be used. Roughly 10,000 of them, 11,000 of them, have no hazard data whatsoever. That's 66%. Of those for which there are hazard data, 4,200 were hazardous. 1,100 or 1,200 were less hazardous. and only 161 chemicals were not hazardous, at least based on the incomplete evidence that's available. No chemical, especially no plastic chemical, has been tested fully for hazardous characteristics. So what are these chemicals in plastics? And why are they there? You've got the monomer that's present. That's the building block, the building block that becomes the polymer of a plastic. They can be toxic. You've got additives to plastic like the phthalates and sometimes bisphenol A. Bisphenol A can also be a monomer. You've got what are called non-intentionally added substances, which are, if we had an accurate count of what are called NIAS, that 16,000 number would be much higher. We know that they're there using appropriate chemical measurement techniques, but we can't identify them. And they result from chemical reactions in the processing of plastics. Because plastic is good when it's cheap, companies make plastic like cheap plastic. They never have reagent level starting ingredients. So there are always contaminants in the plastics that they use, including in the medical plastics that you all depend upon. And lastly, there's the whole problem of adsorption and absorption, which is particularly a problem in marine environments. So I won't spend a lot of time on that. To what do they contribute? Well, cancers, cardiovascular disease, reproductive disorders, brain-related disorders, immunological problems, and metabolic diseases. There is lots of publications in the scientific literature documenting plastic chemical contributions to each of those conditions. The types of chemicals that are involved are quite diverse. Here's a list from that study, the Plastichem report from Norway. And while we can look at all that list and see a variety of types, including the bisphenols and the phthalates, in each of those families, there are, if not all of them, many of them are endocrine disrupting chemicals, EDCs. I'm going to spend the rest of the time talking about EDCs. It's what I've studied for a long time. Where do they come from? Well, they come from the endocrine system, and they go to glands throughout the body, where they're from glands throughout the body, and they go to cellular receptors that need them. Where are they made from? They're made from by the petrochemical system. What are sources of exposure to EDC chemicals? Plastics, obviously, industrial chemicals, pesticides, personal care products, food packaging. And food packaging is especially interesting and important because there's clear evidence of widespread exposure to food contact chemicals in which the concentrations of the chemicals that leach from the plastics into the food are in the parts per million. Whereas if you study the concentrations of pesticides in food, at least in this coming from supermarkets, they tend to be in the parts per billion. And you know what? I just realized that I started the wrong slide. So give me a second here. I'm going to end the show and go to a different deck. I apologize for this mistake. It's the same talk out until now. So excuse me for 1 second. I'm sharing the screen. This is where we are, and I will quickly go to I'm so sorry. It's late here on the East Coast, and that's my fault. But up until this point, everything is the same. So what do EDCs and endocrine disrupting chemicals do? They hijack hormone signaling. Hormone signaling, as you all know, is it conducts the symphony of life, all those genes being turned on and off trillions of times a second. Infinitesimal amounts of hormones determine when genes turn on and off throughout our lives. There are some really extraordinarily beautiful cellular mechanisms that amplify those signals. In essence, the hormone signaling system is one big amplifier, sending those signals and making sure there's enough of a message getting to the recipients. But the key thing here is that hijacking those signals with EDCs can disrupt signaling in many different ways. One vital element of this is EDCs are effective at very low concentrations. Here you have a display of the concentrations at which hormones, this lower green line, and EDCs, the upper green line, bluish green line, the concentrations at which they typically are active, physiologically active in cells. And it's in the, particularly for the hormones, it's down to low parts per trillion, running into the medium parts per billion, and EDCs are just a little bit above that. But typically toxicity is studied in this higher range in parts per million. And what I'd like to do is ask you a question. Are the low doses considered by toxicologists and EDC specialists really low? What is a part per billion? Well, some friends of mine calculated this, that a part per billion is one pancake in a stack of pancakes 4,000 miles high. Sounds pretty small, infinitesimal. But turn it around. What is a part per billion? How many molecules? If you have a drop of water and its concentration of BPA in it is 1 part per billion, how many molecules of BPA do you think are in that single drop? 2.65 trillion molecules of BPA are in that one drop if the concentration is 1 part per billion. Now, there are a billion times more molecules of water or whatever the liquid is, but 2.65 trillion is a lot of molecules, especially if you have a system that's designed to amplify the signal by over 1 million-fold from receptor receiving the hormone to the ultimate production of enzymes and proteins by the ribonucleic system. So 1 part per trillion is not really low. Here's a word cloud is listing a wide array of conditions that are associated with endocrine disruption exposure. The level of certainty varies significantly among those different conditions, but for some it's quite robust, and others it's good. I want to give you one example that illustrates the complexity of dealing with endocrine disrupting chemicals, hormone signaling being hijacked. This is the inside of a mouse. It's an adult mouse about my age. Experiments done by Fred von Saal, who's one of the world's experts on bisphenol A. And he took his experimental animals. This is the control animal. It's got a normal bladder. It's got kidneys that are just fine. It's a male, this particular animal, because it's got testes. And he took the experimental mouse and exposed it to 20 parts per billion of bisphenol A during pregnancy. There's a difference. The adult male mouse on the right has a bladder that's about to explode, literally. It would have died not too long from now if it had been left alive. Its kidneys have gone completely necrotic. It's still a male. But what happened? That small, seemingly small amount of bisphenol A, 20 parts per billion, altered epigenetic programming in the prostate, so that as that mouse aged from fetal life through to my age in adulthood, its prostate responded to a change in the ratio between estrogen and testosterone, which happens in mice and it happens in men, lower testosterone as they age. And the response of the urethra, which is the tube through which animals like mice and humans pee, that urethra in the prostate constricts the opening in the urethra so that sooner or later the animal can no longer pee by the time it's my age. This was caused by very subtle initially effects in epigenetic programming of tissue in the prostate. Lifelong effects that were just not at all detectable at birth of those animals. A second experiment that I think illustrates a very different type of effect, but very powerful effect, just came out this summer, looking at male autism spectrum disorder. And it turns out that there is a relationship, this is a prospective study, a relationship between BPA exposure in the womb, in babies, and the likelihood of autism later in life. And that the increase in autism rate was quite striking. Boys born to mothers with high urinary BPA levels were 3.5 times more likely to have autism by age of 2 and 6 times more likely to be diagnosed by the age of 11. And this publication was especially strong because they worked in mice also, and they were able to determine that the BPA was associated with changes in aromatase activity, a reduction in aromatase activity in the brain of experimental mice that led to the testosterone that normally is converted to estrogen in the brain to be not converted. So there was more testosterone in the brain than there normally would have been. This, I think, is an interesting observation that they found that the fatty acid 10-HDA was able to suppress the mouse phenotype, and they're working on that, following that up now. So here we are on a growth path towards what is clearly going to be unsupportable plastic production by 2050, unsupportable. You will, I hope, be interested to learn that next month there is a 5th meeting of the Conference of Parties involved in developing a UN treaty, which we hope will put a cap on production and start to lead to a decrease in plastic production. But we've also, as I said right at the outset, we find plastic to be quite useful. So what do we do? We do have to reduce its production. We have to start thinking like a chemist to redesign how plastic is built, what its molecular structure is like, and how do we design new plastics that aren't capable of binding with the receptor systems that are crucial to proper hormone function. And then something I could go on at length about, we've got a horrendous regulatory system that just does not pay attention to modern endocrine science and is leaving us vulnerable to all sorts of problems. Just as one example, the Europeans 2 years ago reduced the acceptable dose of bisphenol A by a factor of 20,000-fold compared to what their acceptable daily intake, safe daily intake was, 20,000-fold, whereas the US, its acceptable daily intake began 5 times higher than the Europeans' estimate before the Europeans reduced their tolerable daily intake. So now Europe has the TDI 100,000 times lower than what's in the US. So we've got these 3 R's to pay attention to. Here's my daughter, my granddaughter now, Sarah Rose. She's 5. She's not out of the woods yet, but we are really pleased to see how she is developing after all that plastic exposure. And I think it has to do with how my daughter and her husband have been challenging her all the time. All of us here, I hope, are concerned about the plastic industry's continuance in ignoring unintended consequences of their innovations over and over again. We can reverse their errors, but the challenges are daunting, but they're not impossible. Now that we know what the threats are and can look clearly eyed at what they've done and the mistakes they've made, and what opportunities we have to redesign, to work with chemists to redesign plastics, we can do something better to respond to this challenge. Thank you very much.
Thank you so much. And Dr. Myers, that was a wonderful presentation and so enlightening, but it seems like it's really a daunting problem. And, you know, we do find ourselves completely surrounded by it. As a recent article in the New York Times, A Day Without Plastic, and they highlighted how difficult it is. The journalist said, I'm going to try not to touch plastic for a day. And he wound up bringing a wooden chair to sit in the subway. So it's really a difficult problem. And it's one that we don't know a lot about and physicians don't know a lot about. And you highlight that. There's so many articles about the microplastics, and maybe we'll have a question about that at the end, that are in, in carotid arteries, and they're in kidneys and all of that. I mean, and the endocrine disruption aspect of that it's daunting to think about it. So thank you so much for your leadership on this, and just, your honesty as well. So we're going to have a lot of questions for you at the end. So thank you so much, Dr. Myers. That's awesome. And I'll also put in the chat a couple of other videos that might be useful for people in the chat once we start the next talk. So it's my distinct pleasure now to introduce our last speaker, Dr. Ray Dorsey, who's going to present the root causes of Parkinson's disease. And Dr. Dorsey is a professor of neurology at the University of Rochester. He's dedicated his career to finding and eliminating the root causes of Parkinson's disease. He's co-author of Ending Parkinson's Disease, A Prescription for Action, which was published in 2020. And I've read the book, and it's brilliant. It's really clearly written. It tells the tale of Parkinson's for physicians and anyone else who cares to learn about this disease, which increasingly affects not only our patients, but also our family and friends. So it's in the must-read category along with Our Stolen Future. A couple of books today, book club. Dr. Dorsey's also published an abundance of research on Parkinson's, which is now the fastest growing neurologic disorder in the world. He's found that there's a small contribution from genetics, but a much larger influence from the environment. He'll tell us about that tonight. Dr. Dorsey's examined the multifactorial causes of Parkinson's disease, noting links to pesticides and industrial chemicals, many of which are still in use, contaminating our air, food, and water. His articles have been published in leading medical and economic journals and have been featured on National Public Radio, the New York Times, and the Wall Street Journal. In 2015, the White House recognized him as a champion for change for Parkinson's disease, and he's previously directed the Movement Disorders Division and Neurology Telemedicine at Johns Hopkins. Dr. Dorsey completed his undergraduate studies at Stanford University, medical school at the University of Pennsylvania, and business school at Wharton. Thank you so much for being here to speak with us tonight, Dr. Dorsey.
Thank you very much, Dr. Russell. Delighted and honored to be with you and Dr. Myers and Dr. Diadamo. I'm going to build off exactly what they said. Every society creates its own diseases. Every society creates its own diseases, and we're seeing some of the diseases that are being created in terms of autism. 1 in 36 children 1,000 years ago did not have autism. 1 in 36 children when Dr. Myers and I were children did not have autism. One of the diseases I think society has created is Parkinson's disease. And I'm going to argue to you that Parkinson's, the world's fastest growing brain disease, is essentially a man-made condition, and that we need not even have Parkinson's disease. And indeed, for 99.9% of history, we likely didn't have Parkinson's disease. The first major description of Parkinson's disease was in 1817 by Dr. James Parkinson, a 61-year-old British surgeon who saw something new on the streets of London. And what he saw that was new wasn't a tremor. He said that's long since been described. Even Shakespeare describes tremor. But he says what's new is that people are walking with a tremor, a stooped posture, a tendency to walk faster and faster, and to fall forward. And if you think about it, if you're a 61-year-old physician, you're not going to take time to write a case series unless there's something different. It really needs to get you out of your chair to do it. And so he wrote this long case series of 6 individuals with the disease. And 200 years later, the Global Burden of Disease study estimated that 6 million people had the disease. So you went from a disease that 6 people had, that he said had not been classified in the medical literature, those were his words, to a disease that affected 6 million Americans. The Global Burden of Disease earlier this year said there were nearly 12 million people with the disease. How do you go from 6 million to 12 million? It clearly can't be genetic. Genetics doesn't change that fast. Aging alone doesn't do it because it's growing faster than aging. It must be our environment. And I think there are 3 major things in our environment that are causing it. The first is what Dr. Myers showed to you in Northern California and what Dr. Parkinson was experiencing in 1800 London, and that's air pollution. Air pollution was so bad in 1800 London, it was equivalent to what Dr. Myers showed you in Northern California. It's equivalent to what New York City experienced in 2023 during the Canadian wildfires, when the skies over the Big Apple turned orange, and what people in Beijing, China, and Delhi, India breathe on a daily basis. And so I think Dr. Parkinson's describing the chronic effects of very, very high levels of air pollution. And an increasing number of studies have linked air pollution to Parkinson's disease and especially to Alzheimer's. If you think about this, air pollution is inhaled. The little pieces of tiny particulate matter, they carry with them toxic metals like lead from leaded gasoline, iron from brakes, platinum from catalytic converters. The pathology of both disease begins in the olfactory bulb, the smell center, with misfolding of alpha-synuclein for Parkinson's or misfolding of beta amyloid for Alzheimer's. And loss of smell is one of the earliest features of the disease. For those of you who remember, I don't know if you doctors remember the blood-brain barrier really doesn't like things to come in. And what the nose is the front door of the brain, and it bypasses the blood-brain barrier. And so I think these particulate matter are the Trojan horses on which toxic metals are hitchhiking to enter the brain through the olfactory nerve. So that's one. The second major risk factor are pesticides. We've heard a lot about them today. Pesticides are, for most of them, many of them are nerve toxins, so it's not terribly surprising that if you inhale or ingest nerve toxins, you might be at risk for neurological disorders. Indeed, the great study from Columbia University, Virginia Rao has shown that umbilical cord levels of chlorpyrifos is a pesticide that almost all of us have consumed. If you've ever had an apple, over half of apples in the United States used to have chlorpyrifos on them, and because of a legal judgment, they were likely to have them again. But umbilical cord levels of that pesticide are associated with lower IQ at 3, 5, and 7. So if you want to have children who are less bright and populations that are less intellectual, we should continue to have widespread use of pesticides. And it turns out there's one pesticide, not chlorpyrifos, which is also linked to Parkinson's, but a pesticide called paraquat. It's a weed killer. It's created in the 1950s, been used since the 1960s. It's considered one of the most toxic weed killers ever created. It kills the weeds that Roundup doesn't. It's been used to commit homicide and suicide. The EPA's own website says 1 sip can kill. China has banned the chemical, which is associated with a 150% increased risk of Parkinson's disease, but the EPA earlier this year reauthorized its continued use. It's sprayed in the Central Valley of California, which not coincidentally, I think has one of the highest rates of Parkinson's disease in the country. And it's sprayed on corn, cotton, soybeans, and vineyards throughout the United States. And then the third chemical is a chemical that I knew nothing about until I had the gift of a sabbatical about 8 years ago. And it's a chemical called trichloroethylene. It's a really, really simple molecule. It's got a whopping 6 atoms. 2 carbons in black, 1 hydrogen in white, and 3 chlorines in green, hence its name trichloroethylene. It's got a cousin called perchloroethylene with 4 carbon atoms. If you dry clean your clothes, you're likely getting exposed to perchloroethylene, which has recently been banned in California. This chemical trichloroethylene is a known carcinogen. There's no debate about that. Virtually every regulatory agency says it causes cancer. And perchloroethylene is a likely carcinogen. The two of them are also associated with a 500% increased risk of Parkinson's disease. These are also the 2 principal contaminants of the marine-based Camp Lejeune. So if you're wondering why you see all those Camp Lejeune ads, it's because Marines for 25 years at least drank water that was contaminated with these chemicals, and the U.S. Marine Corps knew about it for the latter years and did nothing. And by nothing, I mean that they knowingly allowed the best and brightest of Americans to be exposed to cancer-causing chemicals in the water they drink. Same water was actually used to supply the hospital, so people could have cancer surgery from the base, and as part of the recovery, be drinking water with carcinogens in them. And by nothing, I mean they refused to notify individuals of their exposure even after the fact, until an act of Congress forced them to do so. And so that's why, in addition to the heroism of a Master Sergeant Jerry Insminger, whose daughter died of leukemia while he served on the base, and he spent the last 27 years bringing justice to Marines, the million Marines, civilians, and dependents who served between 1953 and 1987. It turns out that TCE doesn't just contaminate Marine Corps bases. It's the same chemical that was in Woburn, Massachusetts, and caused children to develop leukemia, as depicted in the movie and the book A Civil Action. It was in Toms River, New Jersey, which was depicted in the Pulitzer Prize-winning book Toms River. It's in Northern California, in Mountain View, California, where there are 15 Superfund sites along a 7-mile stretch of the 101 freeway that are contaminated with trichloroethylene. And trichloroethylene not only can contaminate groundwater, and that's one way to get exposed, but it, like radon, can evaporate from groundwater and soil and enter people's homes, schools, and workplaces. Actually, I think this is a huge issue that is completely missed by most of the public, and quite frankly, most doctors. I didn't know about this, and most cancer specialists and most environmental scientists, that there are children, I think in Rochester, New York, in Newport Beach, California, in Franklin, Indiana, who are breathing in or have breathed in these cancer-causing chemicals as I speak right now. Numerous animal studies have shown that air pollution, paraquat, and trichloroethylene can reproduce the clinical and pathological features of Parkinson's, including animals developing a tremor. So if Parkinson's is indeed man-made, if it's due to these environmental toxicants, I think then it can be human-ended. And so every time I see someone with Parkinson's, I get pissed off because I think it's completely unnecessary and completely avoidable. If we get rid of these toxins in our food, water, and air, we get rid of Parkinson's disease, the vast majority of it, we get id of it, and we get rid of a whole host of other neurological and medical conditions. I think that's incumbent on us. You know, lots of scientists and physicians are listening today, and we have an obligation to the communities that we serve. I think I have an obligation to the Parkinson's community. And when Dr. Russell says Parkinson's is the world's fastest growing brain disease, well, whose fault is that? And I think it's on me. It may not be my fault. I think we have chemical companies to blame, and we know from reporting from The Guardian that the chemical companies have systematically hid the toxic effects of their chemicals from regulators, from publics, and sought to discredit scientists. I wouldn't be surprised if people were after Dr. Myers and his great work on endocrine disrupting chemicals, because the chemical companies know about it just like the tobacco companies know about the risk of smoking. But it's incumbent on us to be accountable to the communities that we serve. And I can't think of a better gift that I can give future generations than a world where Parkinson's disease is increasingly rare, if not non-existent. We've gotten rid of diseases in the past. We live in a world largely free of polio. We've gotten rid of typhus. We've gotten rid of yellow fever. We've gotten rid of scrotal cancer. The list is long, and we should add other conditions to it. And I think Parkinson's disease is another one that we should add to that list.
Great. Wow. Thank you. I've been putting a couple of references in there for people because I have looked at that study, and that was fabulous. I mean, you've done just amazing work around this. I just really appreciate it. We all appreciate it, what you've done. We're going to probably just go to Q&A now, I think. I want to let everybody know, just go ahead and put your questions in the Q&A, and we're going to start, sorry. But thank you all, to all of our speakers tonight. Just amazing presentations and changing our perspective. And hang on, and we're gonna start here. I'm so sorry.
Could I add something to Ray's comments?
You bet, absolutely.
Ray, I have worked with a lawyer that Debbie Corey Schlecht has worked with and knows the paraquat case exceedingly well. You described what happened, the details of what happened, the details of what two companies did over a period of 5 decades should have them in jail because they lied, they hid, they distorted data. It's all in, and it was all in their files there to be discovered by a lawyer and colleagues. And it was brilliant work. My favorite document in those files was the bill that the company sent its insurance company to pay for the costs of defending against this lawyer. The bill was over $100 million from the insurance company to the insurance company for the cost of defending against a lawyer fighting to end Parkinson's. So I want to thank you for the work you've done in that. It's so crucial, and everyone, he got it right, totally right.
And I think we're being had. You know, if you look at this really, really, really clearly from an external perspective, you could say that people like me, well, Dr. Myers is not a clinician, I basically clean up the work of chemical industry. That my job is to clean up the work of chemical industries. Now, many of us went to medical school for many different reasons. None of us went to medical school to clean up the work of the chemical industry. The knowledge that we do not have, the ignorance that we do not have, is a direct reflection of people knowingly concealing information that if scientists and the public knew, we would lead to different decisions. I shared this concept with my friend who's an English professor, and he introduced me to a new word, agnotology, and I put a link in it. And science is the production of knowledge, and agnotology is the deliberate production of ignorance. And we've been had. And we've been had in the past. We've been had with lung cancer and smoking, you know, when those risks were concealed. We've been had on opioids. You know, when I was in medical school, I was taught that it was almost impossible for a person to become addicted to opioids if they were in indeed pain. We've been had on social media and the effects that it has on children, and we're being had on paraquat and pesticides. And if we're being had on all these things, we should think about what else are we being had on? Are we being had on Dr. Myers' work around endocrine disruptors? Are we being had on trichloroethylene? Are we being had on a wide range of other chemicals? There is a reason that cancer rates are increasing in Americans under 50. There's a reason 1 in 36 children have autism. There's a reason Parkinson's disease is among the world's fastest growing brain diseases. Diseases have reasons and they have causes. Hippocrates said that these are diseases are the accumulation of small sins. And there are lots of small and big sins that people are perpetrating on scientists, the scientific community, and the communities that are being affected by the diseases. And this would be a great forum for the scientific community here to stand up and speak really loudly and clearly, because some of the scientists who are out the forefront of this, I've had attorneys, I've had people issue me depositions at my door with my teenage son having to answer the door because of the work that I've done. And I'm not even a consultant to any industries or any legal firms on this. I am purely just an academic writing the research itself, and they're coming after me. And if they're coming after me, they've come after Dr. Debbie Corey Schlecht, and they will come after others. And they especially love to come after women, by the way. Just if there's a woman doing it, they just love to attack women. So, you know, Rachel Carson being, you know, the poster child for that. So I think our community really needs to wake up and recognize, I think this community might recognize it, but we've been had. We've been had in a big, bad way.
Thanks for.
Well, and I think, you know, that is leading to the questions. We have many questions that are starting here, but I wanted to ask you this question about industry influence for both of you. And so, Dr. Dorsey, you referred to this recent report. There was a shocking investigative report in The Guardian where journalists revealed how industry advocates established a private social network to counter resistance to pesticides and genetically modified crops in Africa, Europe, and other parts of the world, while also denigrating organic and other alternative farming methods. And more than 30 current government officials are on the membership list, most of whom are from the U.S. Department of Agriculture. And these members have access to a wide range of very personal information about individuals deemed a threat to industry interest. The authors, Michael Pollan and Mark Bittman, are on the targeted list. And Pollan's portrayed as an ardent opponent of industrial agriculture and proponent of organic farming. And it's interesting that the records show that a former Monsanto executive and founder of V-Influence led the effort. He advised U.S. officials and attempted to sabotage opposition to products created by the world's largest agrochemical companies. And V-Fluence is named as a co-defendant in a case against the agrochemical firm Syngenta, and they're accused of helping Syngenta suppress information about the risks of the paraquat weed killers, which could cause Parkinson's, and of neutralizing its critics. So I have a question for you. Do you know, that study just came out. Do you think you're on that list, Ray, or sort of?
I haven't seen this list, but let's just take Michael Pollan, for example. Michaal Pollan, who has written great books on nutrition that many of us had read, Omnivore's Dilemma among them, is the brother-in-law of Michael J. Fox. And Michael J. Fox says that he got Parkinson's from exposure to some kind of chemical. Just think about that. Probably one of the most credible people. I don't know Michael Pollan. I've never even met. I've only been in the room with Michael J. Fox once. He doesn't know who I am. But it is
I'm sure he does know who you are.
That they are attacking Michael Pollan on this around the brother-in-law of the most prominent person with Parkinson's disease in the world, who thinks he got Parkinson's from some kind of exposure to some kind of chemical. And I think he's right. It just tells you the extent. And this is taxpayer dollars. This is our taxpayer dollars that are being used to subsidize these attacks on scientists and science. And we're taking this like we're just bending over backwards to accommodate it. We should not.
Right. And I'm just going to continue before we ask Dr. Myers a question. There was the secret, this is something you alluded to, the secret paraquat papers. They revealed the corporate tactics to protect weed killer linked to Parkinson's disease. And I think I put a link to it in there. Can you describe some of the tactics used by industry to attack credible science and or suppress good policy that you've experienced or that you know that others have experienced? I'm going to ask the same question to Pete.
Dr. Myers.
Dr. Myers. Dr. Myers, go ahead, Dr. Myers.
Please. My deepest knowledge about something like that is actually not chemical companies attacking me, although I have been. It's Tyrone Hayes. Tyrone Hayes is a distinguished professor of biology at UC Berkeley. But when he was a young assistant professor, Black assistant professor at UC Berkeley, he was looking for money. And he went to a firm. This is now in the public domain, been written about many times. He got money from Syngenta to test the effect of atrazine on frogs. And he started to find some really nasty things. And I learned about this because the two of us were being flown repeatedly to Tokyo to lecture in Japan on endocrine disruption. And we spent time in the bars together late at night. And he told me these stories about what Syngenta was doing to him. And it was amazing. And it was so amazing. I didn't believe it. But fortunately, he was an assistant professor at Berkeley. And I had gotten a PhD at Berkeley, and the chairman of the Berkeley department had been on my PhD committee. So I called him up and said, Dave, is what Tyrone's telling me true? And he said, absolutely. I've been in the room when Syngenta's been pushing him around. And the key for that is that Syngenta, the way EPA works is if you're still doing the study, you don't have to report it. You can keep, and so if Syngenta can keep Tyrone still doing the study, he never has to report it. But Tyrone, being a straight shooter, wanted to put his results out. He has frogs. His study animal is a frog that, when exposed to atrazine, about 10% of the genetic males become fully functional females. So he had this result and some other results also, not quite as striking as that, but Syngenta wouldn't let him publish it. They said, no, you just keep doing the study. We'll keep giving you research because you need money. Don't publish. and we'll never have to take it to EPA. So Tyrone, fortunately, we got to be friends, and I was running a foundation at the time, and I arranged for him to, I got money for him to be able to repeat the studies Syngenta would not let him publish. So he repeated those studies, got the same results, published it in PN, the Proceedings in the National Academy of Sciences, like not a trivial place. But it got really bad as he was lecturing widely on atrazine and frogs. He was testifying before the Illinois State Senate. And by then he was used to having Syngenta toadies following him around to all his speeches. And at this place, at the hearing room, this guy sidles up to him. Tyrone knew he was a Syngenta guy. And he comes up to Tyrone and says, "Gee, Tyrone, you travel a lot. Don't you worry about your family?"
Wow.
That happened. And that's now, it was found in court I mean, it's been totally revealed publicly through disclosure efforts by various lawyers who were just trying to defend Tyrone. Anyway, it can be that bad or it can be worse. I personally have had a relatively light treatment. My co-author in Our Stolen Future, Theo Colborn, had it much worse.
Well, thank you. We have a couple of questions from the audience. Thank you. This is actually would be a great discussion for many hours. So we have a question about TCE, and Dr. Dorsey, can you expound on the Mountain View TCE exposure, which is local to us? Is this a forever chemical, or is there a way to remove it through mitigation cleanup?
So it's all over. There are 15 Superfund sites. TCE was widely used to clean off silicon wafers in the 70s and 80s. And so there's Superfund sites from Intel, super sites from Fairchild Semiconductor, and many others. Up to 30% of groundwater in the United States contaminated with it. And it evaporates into people's homes, schools, and workplaces. So it is almost certain that there are homes in Mountain View, California that have TCE in it right now. In our book, we highlighted, gosh, I forgot her name. It'll come to me in a second. Who had TCE in her house? She was located across the street from one of these Superfund sites. Jane Horton. So here's the map of all the TCE contaminated sites in Mountain View and California. And this is Jane Horton. And the nice thing about TCE, the good thing is that just like radon can be remediated, TCE can be remediated. You basically suck the air from underneath your foundation and vent it above your roof, and you can have clean air. Ms. Horton says that she has the cleanest air in indoor air in Mountain View, California. So the remediation is relatively trivial. It's about $1,000 to $2,000 per home, which is, a small fraction of the value of a home in California.
Yeah. How would you test for it? You
test for it just like the similar way you test for radon. Again, I'm a neurologist, I'm not a toxicologist. You get something called a sumo canister, which sucks the air from your home. Ideally, you do it in the winter when pressure in your home tends to be even negative. So negative pressure sucks the air into the house. And then the remediation is relatively straightforward. It's estimated 1 in 15 homes have high levels of radon in the United States. I don't know what the number is for TCE, but this is a huge issue. I think something like 70 million Americans live within 3 miles of a Superfund site. And maybe Dr. Myers can help me out here, but it's really, really common, and it's slow to break down.
It's slow to break down, but it's not as bad as the forever chemicals, the perfluorinated chemicals, because of the specific chemistry of those perfluorinated chemicals that there's nothing in nature that breaks them down. The chemicals that Ray was just describing do ultimately break down in nature, but they're around for a long time and they contaminate many places. And even though it may cost only $1,000 a home, there are a lot of homes. And so it's actually turning out to be very expensive.
And people don't realize it either. They might not even, who's not watching this forum or reading your book, they don't know about it. and then they
I
just
didn't
have
know
a
about it.
disease,
I mean,
and you know,
I think with like,
just,
you know, Dr. Meyer started his story with a personal story. I mean, we're all at risk. I mean, there's a reason 1 in 8 women have breast cancer. I mean, think about that. 1 in 8 women have breast cancer. If that was true 500 years ago, would we be alive? I'm not so
Right.
sure. 1 in 8 men get prostate cancer. Really?
And it's increasing.
Yeah,
And it's
it's
increasing.
increasing.
They're
And
both in.
there are reasons why these things are happening. And it's not just because we're great diagnosticians. You know, we need to take a little hubris out of this. It's not great. We're doing mammograms and stuff like this. It's because people are getting sick and there are reasons for these illnesses.
Right. There's another question about TCE. TCE is well known to initiate autoimmunity. Is this a mechanism in Parkinson's?
It's definitely associated with autoimmune disorders. And, you know, I've learned far more about TCE than I ever thought. I don't remember ever learning about it in medical school. I don't know the mechanism for autoimmunity, but I've met lots of Marines who served at Camp Lejeune, and I went to go visit. I'll tell you a little vignette. I went to go visit Marines in Winchester, Kentucky. They were coming together and they wanted me to come speak. And I was ready to go meet Marines, you know, Marines who were going to go kick my behind. And I haven't seen a more sickly lot of people in my life. I mean, there were men losing their hair, men with Sjogren's syndrome. There were so many male Marines who developed breast cancer at Camp Lejeune that they created a swimsuit calendar of men showing off their mastectomy scars.
Wow. I put a link to Camp Lejeune. There's another video. I'll see if I can put a link in there in a minute. We have another question. Thank you so much, Dr. Dorsey. Dr. Myers, there's a couple questions about plastics, and I want to ask about, there's a couple questions related. The first one is, what can you say about the reality of and safety of plastic recycling? We have it in clothing, housing, artificial turf, and then go to the prospects for breaking down plastics in landfills and ocean through plastic-eating microbes.
The question of toxicity related to recycling is a very serious one. It's another example of what Ray described of companies manufacturing doubt. That's another term. What did you call it, Ray?
Agnotology. But
agnotology. The other term is manufacturing doubt. And that works because if you're a lawyer working for a chemical company or tobacco company or whatever, and you can get the judge to think there's an argument between scientists that hasn't been resolved yet, or do the same before regulators, get them to believe that this isn't resolved, then he will, in essence, he or she will say, come back to me when you all agree. So one of the principal ways that companies manufacture doubt to defend their products, or one of the principal ways that they prolong the use of their products way past when science tells them that they're dangerous is by manufacturing doubt about the science. And it's not real doubt, it's manufactured doubt. And I forget what your question was.
Oh, and then just just really, what is the reality of plastic recycling and the safety of it?
That's right. Sorry.
That's okay.
I had the privilege of being in New York City 2 weeks ago at a series of meetings where this Attorney General of the state of California, Attorney General Bonta, announced that he was suing ExxonMobil for 50 years of misrepresenting the efficacy of recycling. And I started off on this manufacturing doubt because that's what ExxonMobil did about recycling. Recycling, first of all, it doesn't go to scale ever. It will never catch up with the amount of plastic that's produced. And second, there's now good evidence that says if you have a piece of plastic that is not toxic, and in the recycling process, you combine it with something that does have toxicity, the result in that recycled thing is more toxicity. Toxicity increases with the generation of recycling that's taken place. Toxicity means that plastic will never be part of a circular economy as much as we might wish it to be. And Attorney General Bonta, he was amazingly familiar with the science of all this. I heard him give the same talk 3 times because he went to 3 different meetings I was attending, including one with the Attorneys General of the United States. He's going to he is representing the people of California in a trial over the failure of recycling and the role that ExxonMobil did in misrepresenting what it could possibly do. Basically, ExxonMobil was trying to make sure the responsibility for plastic trash was on us, not on the company. It was on us. And if we didn't take care of it, it was our fault. But there are documents, just like there were in the Parkinson's issue, there are old documents that said, from one of the principal representatives of the plastics industry, one of the trade association or plastics industry, literally recommending in a meeting to people in the plastics industry who were just confronting the transition where there was so much plastic around, they had to figure out how to begin to get rid of it, the waste. And the plastics industry person says, your job is to make people live with waste, accept waste, accept recycling, because it will make them feel good, even though it doesn't mean anything.
All right. We have a couple more questions. We want to end mostly right on time because this has been late for you guys. It's 3 hours later there. So if people are tired on this forum right now, you guys are amazing. And I can only imagine, just because you travel around so much, you're used to all these weird hours, that you're able to do this tonight. So let me ask you a couple more questions. Is there any prospect for breaking down plastics in landfills or through those plastic-eating microbes? And I think you've already answered the question, would this worsen the potential toxicity of plastics through releasing toxins? And the answer probably to that is yes. But do you know anything about?
Yeah, I do. And there are all sorts of wonderful projects, wonderful people, well-intentioned people trying to make recycling work, but it doesn't go to scale. Remember that graph I showed of the rate of the increase of plastic production? You're never going to catch up. We only recycle somewhere between 5 and 10% of plastic in the United States, and that's being generous. And it's only going to get worse. It's not, and the microbes, they are a great idea for small scale possible use, but it will never reach a scale capable of dealing with the plastic problem.
Okay. And Dr. Dorsey, this is for you probably, and for Dr. Myers as well. What can we do to really, what are the most important things we can do about our lifestyle to really avoid toxins and to prevent Parkinson's disease? And I have a couple more questions I want to ask after that. So
I think there's some great individual things you can do. Buy organic, wash all your fruits and vegetables with water and soap, a pesticide wash. I put a carbon filter on my water. If you have a private well, you better get that thing tested for pesticides and trichloroethylene. You should put a carbon filter, from Pure or Brita, whatever you want, on your water now. I don't use a dry cleaner that uses perchloroethylene. I strongly urge you not to do that as well. Exercise, decreasing exposure to animal products as they magnify these toxins as they move up the food chain. These are all things you can do. We're writing another book called The Parkinson's Plan with 25 things you can do individually. But fundamentally, our environment is a product of societal decisions, not individual decisions. And so we need to make changes at a societal level. And there are things we can do locally. I think one really powerful thing we should do is we should forbid pesticides at schools. They already do that in California. It's called the Healthy Start Act. Dr. Myers could probably help me out here. And schools in California aren't allowed to use pesticides except for limited ones. And when they do, they have to notify the parents. Why are we using pesticides on kids' playgrounds? Why are we using pesticides on sports fields? There are several studies that link soccer playing to ALS, and I think that's head trauma and exposure to pesticides. We know pesticides are associated with intellectual disabilities. And I think if we reduce early childhood exposure to these pesticides, we reduce cancer in these children, we reduce intellectual disabilities, we reduce the likelihood of them developing Parkinson's decades or generations later. We might just get rid of a ton of diseases. And I think that's something that we can do in our communities right now and just, why are we using pesticides at our kids' schools?
Yes, it's excellent. And here's another, there's a couple more. So one of them is, there's a couple questions about, yes. Go ahead,
Ray's
Pete.
answer was really good. All those things are things that we can work towards in our local communities, but we need national and international laws that redress some of the problems that he and I have both described, especially about manufacturing doubt. That should
Right.
be criminal activity. It should be jail time. If it can be done,
wrongdoers need to be held accountable. If they're not held accountable, they only get emboldened and they only continue to do it. It's a clear and present danger, and people need to be held accountable. And if they aren't, we see what happens if people aren't held accountable.
the way it's done now, it's a cost of doing business. It's not something that puts the CEO in jail, which it needs to be.
All right, we're going to have another question on artificial turf, and our County Medical Association worked on artificial turf and wrote a policy on this. We have a question about one of the most common constant plastic exposures children get from daycare centers to sports field. Is this artificial turf? Do we think that this might be having an effect on their development? There's shedding microplastics and so forth, and PFAS. What do people, does anybody want to comment on it?
I will, and I'm sure Ray will have something, but I was shocked when I learned that when you recycle artificial turf, and it has to happen sooner than the companies tell you it's going to need to be done, and you put massive rolls of old artificial turf, and you sample the water beside where they're put, there's PFAS. They're forever chemicals that are used in the production of making artificial turf, and it leaches out of the artificial turf. And another striking thing about artificial turf, do you know how hot it gets in the sun? It gets to about 140 to 150 degrees. No kidding. I know people who've measured it directly. And if you have temperatures at that scale, a whole bunch of volatile chemicals are going to be volatilizing from the artificial turf, and it's going to be going into the kids' lungs.
Yeah. All right. I have one last question. I just want to ask people what we talked a little bit about regulation, and I just want to ask about, policy. One of the things that I looked up, Dr. Dorsey, after looking at, thinking we must have banned paraquat here in our wonderful state of California. And I did find that there was a bill, bill number 1963, Friedman, pesticides, paraquat dichloride, was introduced, and the bill would have required the paraquat to be banned. But as it went through the process in the last several months, it just basically fizzled out. The bill was signed by the governor, but the bill was really a shadow of its former self. And it now says the bill would require the Department of Pesticide Regulation on or before January 29 to complete a reevaluation of it as provided and make a determination to retain, cancel, or suspend its regulation. So, I mean, to look at new appropriate prescriptions. So this seems to be one of the many ways in which policy never gets made. I'm sorry, policy doesn't get made because of delay, denial. There's all these D words that you can use. So I just wonder, there was a national bill that I thought was there to remove pesticides or paraquat or something. Do you know about that bill? And so both of you, what kind of policy do we need? Where should we go from here? Is there anything we can do to work on this?
So EPA reauthorized it. Senator Cory Booker, whose father had and died from Parkinson's disease, has a bill that would effectively ban paraquat and change our regulation of pesticides, especially those that affect children. There's another bill I've been told tied to a farm bill that would that would be a federal preemption of state laws that would essentially prohibit states like California from enacting legislation to remove environmental toxins from its environment. The reason we breathe cleaner air in this country, why air pollution is 50 to 90% better than it was in the 1950s, 60s, and 70s, is because California enacted common sense legislation that dramatically reduced environmental exposure to air pollution. The governor of California in the 1960s said we should eliminate all unnecessary driving. Air pollution was so bad. That governor was Ronald Reagan. And another thing that they're trying to attach to this farm bill is preempting lawsuits against pesticide and manufacturers. That tells you all you need to know is that industry is seeking federal legislation to preempt lawsuits against them. What else would a wrongdoer do but seek to prevent people from seeking legal remedies against them?
Wow.
If they can't get exactly what they're looking for there, what they do is they reduce the punitive damages that can be paid to a company by a company that's been found guilty of something. And lawyers can't deal with, unfortunately, the lawsuits that are involved in cases like this are very expensive. And if you want a lawyer to do it, to avoid taking on a case, make sure that they won't get any punitive damages.
Wow. That's just really shocking. We want to support a farm bill, but it's amazing what they can add into it.
Well, I mean, you want to support a farm bill that's aimed at improving the health of the public, not a farm bill that's aimed at improving the health of corporations.
Right. And knowing how, just all the pesticide papers that are revealed, there's a lot to be done. There's a lot to be done. So I really appreciate it. We're going to go ahead and end tonight. We're really grateful to you for speaking tonight. Your presentations were superb. You all are courageous to work to protect individual health and well-being. And you're warning us, you're informing us, you're protecting us and the public with your advocacy, and you're influencing global population health and a cleaner planet for the future generations. And many thanks to you for participating tonight. I want to thank everybody for participating and asking great questions. And I want to thank our staff also at the SCCMA. This will be recorded. You can see it later. And have a very nice evening. And thank you for being here so late. Get some sleep, both of you. Thank you, Dr. Dorsey. Thank you, Dr. Myers. It's such a pleasure. Thank you.
Nice to meet you, Pete. Thank you.